Well, welcome. I'm super excited to be moderating today's panel discussion, which we're calling the 5 considerations for implementing an effective additive manufacturing cell. And this is actually the third of a 3-part webinar series where we've had panelists like the ones that we have today break it all down and discuss what's needed to leverage best-in-class 3D print manufacturing processes. And so if by chance you missed any of the first 2 sessions where we kind of teased apart the hype from the reality, you really don't want to miss those. And so take a moment right now, and if you would like either of those recordings for session 1 or session 2, in the chat, drop your best email, and my team will follow up with you after today's session to get you access to both of those sessions on demand. Okay, you can watch them, and then the MasterGraphics team is going to be available to answer any of your questions to either of those thought-provoking sessions upon your review. So take a moment, go to the chat. If you missed either of the first 2 sessions, you really don't want to miss out on the wealth of knowledge that was shared. Kevin and his team have made a significant investment in the 3D print community and in education and in bringing you this kind of content like you're hearing about today. And so if you missed those, please drop your best email and we'll get those over to you right after the session today. I've mentioned this, but I'm going to formally introduce everyone in a second. Today is a panel discussion. I've got Kevin Carr, David Tucker, Michael Rosplock with us here. And in a moment, I'm going to introduce these experts to you. But let me tell you about our goal here today. In roughly the next 58 minutes, my goal is to dig into 5 considerations you need to make when implementing additive manufacturing, specifically what we're calling an additive manufacturing cell. And my job is to pull out of the panel insights that are meaningful to all of you, no matter where you stand in your journey. But you also, audience, you also have a role to play. Your job is to ask questions in the chat and to engage us in the chat. We like to run these webinars differently. You might already notice that here. I'm hosting the conversation, and it's my job to pull out responses from the panel, but it's your job to participate. And because this is a live, real-time session, your participation in the chat will really influence the quality of the conversation, the quality of the insights that I'm able to pull out of the audience. So I'm going to actively encourage you to ask questions, to reply to the panel as if you're sitting next to them, and engage me and the MasterGraphics team there in the chat, okay? Can you do that? Drop a yes in the chat if you're up for that today. I want to make sure everybody's ready. I want to make sure you know where that chat is, so drop a yes in the chat if you're ready to do that. I see people asking for the sessions. We will make sure to get those to you today. Yes, please give us your best email there. But if you're ready to engage, drop a yes there in the chat. I want to make sure that I can pull out the best information to be able to help all of you in your journey. Let me briefly introduce myself so you know who I am. I'm Dave Rosendahl. I'm going to be the moderator today. I'm the president here at Mindfire, and my company has had a long relationship with manufacturing organizations, both on the 2D and 3D side. And so I've somehow become kind of an industry connector, bringing folks together like the panel that you have here today to advance the industry's knowledge about some very, very important topics that are impacting all of us. And so it's my job to moderate the conversation today, and I am going to be doing my best to pull out the things that are most important to you so that you can get what's on your mind and get that information so that you can start to make some better decisions and improve your outlook in your organization as it relates to 3D print. So let me introduce to you the first panelist today, the first gentleman here on the hot seat, and that's Kevin Carr. He is the president at MasterGraphics. For over 70 years, they've sold wide format and graphics printers, but more recently, they expanded to offer 3D printers from HP, 3D Systems, 3D Platform, and Ultimaker. And today, they're focused on partnering with folks, manufacturers specifically, to help them implement additive manufacturing. And their goal is to help the industry and their partners and their clients successfully adopt 3D. And Kevin's been leading the industry and helping the community learn, much like today's event, so that you can get inspired and take action through events like the ones you're participating in now by gaining insights from industry experts. Kevin, how are you this morning?
I'm doing great. Good morning, and thanks again, Dave, for hosting and leading the event. But good morning, and thanks for all those attending, and of course, our panelists.
Absolutely. And team, Mindfire team, MasterGraphics team, please take a moment drop Kevin's LinkedIn profile into the chat so that folks can connect with him there. And I'm sure many of you are going to want to do that after you hear some of the insights that he delivers to you today. Next up is David Tucker. You can see him here on the screen. David's expertise is in new technology adoption, including new production methods and materials in passenger and commercial vehicles, and in a variety of high-tech verticals. Now, David has almost more degrees than I have fingers on my hand. He's got a double BS in product design and plastics engineering technology from Ferris State University, an operations-focused MBA from Wayne State University, and a master's in technology management from Portland State University. You should throw one more in there, Dave, so I can cover all 5 fingers here.
All right, I'll work
but
on
his professional career is focused on 2 areas. Number 1, making higher value products, and number 2, making products that are easily manufactured. And we know that both those objectives are important to everyone here. So the experience that he has in those 2 areas, I think, is going to serve everyone well. David, thank you for being here with us today. How are you this morning?
I'm doing great. Looking forward to discussing additive manufacturing with this panel. It looks like it's going to be a good time.
Awesome. And team, throw David's LinkedIn there as well. David, I'm sure folks are going to want to connect with you. And lastly here on the panel, but certainly not least, is Michael. Michael leads the research and development of DLMS technologies for application in ultra-high pressure hydraulic products using HP multi-jet fusion printed parts in production. He's also got extensive experience writing business plans to justify these new technologies as production-capable solutions. And that's a topic, a hot topic, how to justify investment in 3D. And so I'm going to make sure to probe Michael for his thoughts on that today, because I know many of you have that on your minds as well. For example, over the course of his career, he's used additive manufacturing to save businesses a combined $3.5 million. So I'm going to probe that a bit today. And with your help here in the audience, let's try to extract as much information out of him today as possible. Michael, we're honored to have you with us today. You ready to share some insights today?
Absolutely. Looking forward to it.
Awesome. And my team's going to throw your LinkedIn there into the chat as well, so everyone can connect with you. Now, I don't want to forget this. For everybody who's here now, if you stay to the end, my team's going to be looking at who's here right now and who's here at the end. You're going to receive the 5 considerations for implementing an effective additive manufacturing cell. This is a new white paper that we're releasing only for those of you who are here to the end of today's panel. So please stick around to the end. I've asked my team to check the roster of who's here, and we'll make sure that you get this white paper the moment it's released, all right? So this is a special gift to all of you who are participating today. So to kick open the conversation here, I want all of you here in the audience to have context for our panel and how they got their start in 3D, all right? So Kevin, I'm gonna go to you first. For those of the audience here who didn't join us for either the first or the second in this webinar series, I'd love for you to tell us a little bit about what drew you to 3D, what challenges you had to overcome to get started, and how you got to where you are today.
No, yeah, so I appreciate it. I mean, I've said this many times before. So when I joined MasterGraphics, we were a big CAD company and we sold wide format. And I sold print my whole life, which companies need. There's value to it. But we were selling this small product from Z Corp. And I noticed that 3D was a little bit different, because when we implemented 3D at customer sites, we really transformed their businesses and opened up new opportunities. So right away, I was like, all right, this is the future. And so, you could always talk about stumbling blocks. And obviously at the beginning, the challenge is where to invest, just like everyone listening today. What's the proper investment? And so, we dabbled in 3D. It really changed when we signed in with HP. We got to focus on production. I think that's been the big, transformation of our business and our clients. And, that's led to other partnerships such as Desktop Metal, AMT, to fill out that production. So, but I think like everyone else listening, the challenge is just where to invest. We've made some mistakes, but how do we continue to be innovative?
Michael, what about you? To just give everyone context for you, how did you start your 3D journey?
So I was one of the, I'm a great case of if you give a mouse a cookie, but I like to say, give an engineer a 3D printer. I took some money from my graduation party going into college, and instead of buying books or clothes or whatever, I took $1,000 and bought a Solid Doodle 3. My parents thought I was nuts. They thought I was the biggest waste of money, and I was the only kid in the dorms on the whole campus. I was actually running a small business printing parts for grad students and engineering, college and stuff before FDM was even common, right? That was back in the early Stratasys days when, it was so expensive to run them and stuff. So I was the low cost option for grad students that didn't have any money. So I got started then, and I fell in love with RepRap. It's how I learned mechatronics. It's how I got into Arduinos, programming, linear slide rails, gearing, all that sort of stuff. So very nerdy pastime that way. Did that all the way through college. And then I went to work, got a real job as an engineer, and 3D printing found me again. I was able, there were just opportunities to bring in a machine here, do prototyping, save money there, went to operations, more opportunities to use it in production. And it just has spiraled from there. Now running the HP cell as a production center in our facility in Columbus, Wisconsin. And then in the background, I'm doing research in metal additive, as you introduced me with. So that's kind of been my journey and where I'm at the moment. So yeah, it's been fun. It's been a wild ride.
Michael, I love that. I'm curious in the audience, who else relates to Michael's story? Anybody else start like that? Anybody else of similar background and start? I think there's probably more than a few people here who can resonate with that, Michael. David, I'm going to turn to you next here. Can you tell us a little bit more about why you were initially drawn to 3D and why you started in the way that you did?
Yeah, so I'm a plastics engineer, my background. And the first time I printed something was in 2000 in college, and I printed a dog bone. Now, as a product developer, I've always 3D printed things over my entire career. It's kind of funny that the person who says they like to create higher value products creates a dog bone as the first thing that they print.
Yeah.
But that's a story in itself. And so I've always used it. I've helped people develop products in injection molding for, it was like 15 years. And I was working at HP, and they actually were releasing the multi-jet fusion system in like 2016. They were looking for someone, they were claiming that they're bringing like form, fit, and function to the additive manufacturing market. And I was like, oh, this is really interesting. And they were looking for someone who understood plastics technology and like how to design products. And so I kind of naturally segued into that, and then really started to understand like, well, how do you validate that a part is functional? Like, how can it, like before it's like form fit, I can like use it as a prototype, but now we're saying it can actually like survive like production use cases. And there I ended up bringing the first additively manufactured parts into the production in their products. And that was like a, pretty significant learning experience, and was able to, kind of like take that and like got really excited about it and started exploring how do you do that for other companies.
I asked these questions of the panel folks so that you have an understanding of where they're coming from in their journey, and so that you can kind of see the world through their eyes as they give responses now to these 5 considerations that we're going to be stepping through. So I want to lead off the discussion here as we get into these questions. And by the way, many of you submitted questions in advance of the event today, so I want to make sure to weave as much of that into the conversation as possible, in addition to the things that I've posed here within these 5 considerations. But I think it's important, before we jump in to the heart of the discussion here, to make sure that we define the term additive manufacturing cell. I think we need to define what we mean by this. So Kevin, I'm going to go to you first. How do you define this term?
Well, it really started with Michael, right? When we sold prototyping machines, you didn't need processes, people, and technology kind of wrapped together. And as Michael implemented this at Enerpac, I realized the challenge that we had in additive, where we were not building the resources around the technology to effectively scale it. And so to me, an additive manufacturing cell basically takes the manufacturing process or thinking and applies it to additive. And in this way, you're creating this cell that's adaptable, can create new things, but with the processes and technologies around it, not just the 3D print, but the finishing and the inspection, to produce an output that is consistent, that has quality to it, and is reliable. So, it really is just taking that additive mindset of producing it and applying it to an additive manufacturing process.
Michael, would you add anything to that definition? You're muted, Michael.
There we go.
There we go.
I was using the space bar, didn't work that time. Yeah, I think, well, first of all, thank you, Kevin. But Yeah, I think that's a great definition. I would add it's really coming down to anyone that has like a green belt or a black belt in Lean Six Sigma. It's all about repeatability. It's engineers can begin working with something once they can predict it, whether that's with a textbook equation, operations gets similar results. Once you have precision, even if it's not necessarily accurate, you can adjust, right? And so it's all about how do you dial in the precision and the repeatability of the machine, right? And that's like Kevin said, I took a very like we'll implement it and we'll update as we go approach. I think that's the only way to do it. And with any technology, this isn't just applied for HP multi-jet, but any additive or really any new technology to a company, there are so many things you don't know about it until you get it on site with your processes and your people and your material lot and all those things. So it really has to be a quick, agile process to go from first implementation to full ISO certification, whatever your end state's going to look like, and how does that process build from step A to that final state. So we really started off with a very fluid, very loose. We're just printing parts. If they look good, great, they go in the bin. To now we're measuring witness coupons, where we have a whole procedure on requalification and powder quality management. And essentially, as the engineers kept asking for more and more and more, we had to keep increasing our requirements and our quality checks and being very considerate of what was going to work for production and what we were capable of doing. And capability, I think, is something we'll talk a lot about today. So that would be my answer. Add to that, I think.
David, your definition of additive manufacturing cells, or anything that you would add or contrast to what we've heard so far?
Yeah, I think what they've said really clearly describes it. I think what makes it additive manufacturing successful, just like any other technology, is the organizational processes that you're placing around the equipment. You can't expect to buy an injection molding machine and have a business just like an additive manufacturing machine. You have to have this cell thinking in order to get that scalable process.
Makes sense. Well, audience, I'm turning to you now. I'm looking at you, Ben, Bob, Brett, Casey, Chris, Colin, Dan, whole bunch of names here. I want to know, how closely does the definition that you just heard from the three panelists here, how closely does that align with your understanding of an additive manufacturing cell? Maybe there's something you would change about the definition you just heard. Maybe there's something that was missed. I'd love for you to drop that in the chat right now. I'm going to give you a second to do that. Think for a moment if there's something there that you would add to that definition. It's helpful for us as we build this conversation to include your commentary here. So please take a moment to do that if something drops out or jumps out at you here. I'm going to turn to consideration one, which is why it's imperative to write an effective proposal to convince company leadership and the technical team that 3D print technology is a worthy investment. And as we look across the industry, we certainly see that there are many organizations implementing additive manufacturing. These companies clearly had to go through some sort of process to justify that investment. And so, David, I'm going to turn to you first here. From your firsthand experience, what are the key steps to justify this kind of investment?
Yeah, the thing that was most successful for me, and this is not a joke, but giving your management something to track. So in most technologies, you have the ability to improve something, drive down costs, drive up efficiencies, and making sure that you understand what you're tracking and how you're actually going to improve these operations going forward, with utilization, costs, efficiency, all of these things that management side of companies are really concerned with. And that's really what's needed to prove out a production application. It's do you have a business case, and is there a way to improve it over time?
So was that one key metric that you landed on, or was it a series of metrics that you used, David?
That was the one that enabled my management to more embracing of the fact that I'm bringing a new technology in. So you have to be able, every technology that a company adopts has to be able to save them money in some sort of way, has to be able to enable higher level product function. So you have to build those rules, kind of around it, and operationalize how you're actually going to manage and use that technology before you bring it inside.
Michael, what about you from your own firsthand experience? I want you to share the experience that you actually went through. What are the key steps to justify the investment from your point of view?
Yeah, I think we've already got a spot on definition here, but yeah, I think you just need to find value, right? It's all about defining what is value to your management. And I think that's, kind of taking that one step back, because that's where you need to start, right? You need to identify the applications, you need to understand what that value is and how you're going to track it, right? So that you can show progress and show the dollars, right? Because at the end of the day, if you ever want to take the step from prototyping to production, you have to be able to show dollars. And whether it's, the pillars of additive value, right? Low volume, high complexity, customization, part consolidation, supply chain disruption, whatever, digital inventory, whatever that means to you, whatever makes sense for your company, I think you need to figure out which of those situations is a pain point for your management team and then tackle that, right? And then work with finance or accounting to put together the equation. How are you going to calculate it over what time period? Otherwise you end up in a lot of situations where everyone knows it generated value, but there's no way to put a number to it. And you end up in these weird soft savings versus hard savings conversations. And if you are very, very specific about it from the get-go, then you can avoid all that. And I think that's something that I've learned, and also something that we've implemented, and that's helped. And just again, looking retrospectively at it, I would have done that even more. I would have doubled or tripled down on being very, very specific about what equation are we going to be able to put on a PowerPoint at the quarterly review and say, this is the value, these are the dollars that this generated for you in cash. I mean, that's ultimately what you're getting to.
Yeah, I see Jordan in the chat there saying, yeah, that's a big point, Michael. So I'm going to stick with you for a second here, Michael. You just used the word specific a few times. They're getting really specific. And I want to get you to be really specific here. Give me something very tactical. And I think you alluded to perhaps an important point there that you might want to dive into a little bit more deeply. But I would like to know something really specific that you think was key in moving the process towards buy-in. Can you identify one thing that is key in that process there?
For us over COVID, it was supply chain disruption. Absolutely. I mean, just a big portion of that 3.5 number comes from, we were able to ship product out the door because we had the printer cell in-house and someone that knew how to design for it and validate those parts and turn them around next day and iterate very quickly to get to a solution that was viable to the customer. And I don't want to go into the specifics of the exact part, but over a series and a handful over the last 3 or 4 years, it's, the big wins are we shipped millions of dollars in product because the printer was there, Michael was there, knew how to work with it, designed for it, it could turn things around quickly. Mm-hmm. Ask your management team how important an extra $250,000 going out the door the last day of the fiscal year is, and ask them how much that's worth, right? And those are the kinds of situations, but and that's the big piece of it, but it's been a mix, honestly. Unless you're a really huge company, it can be hard to draw all the value from just one equation, like I talked about. You might need to come up with a couple and get multiple departments to work together. Cost of quality from operations, manufacturing, fixturing, prototyping for engineering and R&D. And that's really what we ended up doing is to put together no one group was able to justify it, but all together it makes sense. So I think that's another key part.
David, go ahead. I heard you wanted to add a point on there.
Yeah, I think you're describing that higher level value proposition where it's because I use a digital technology, I get pull-through revenue from selling the services that are in my portfolio. And it takes a long time for companies to actually recognize that and to say, oh, if it wasn't for this thing, I don't sell any of this, And so that's the piece that is hard for executives, management inside of companies to until they have the case study to say this is worth $200,000, $500,000. What's it worth to you?
I see Kevin in the chat saying supply chain disruption mitigation is now the highest ROI. Agreed. So let me keep on the audience here for a second. Kevin and the others, Jordan, I see a number of you chatting here. I appreciate that. Appreciate that engagement. I want everybody engaged here. I want to know from the audience, think for a moment, what's something else that you found that's key to moving the process towards buy-in in your experience in the organizations that you've been involved in? Or maybe conversely, if you haven't been able to get that done, if that hasn't happened for some reason, what's the biggest challenge or block that you seem to be running into? Love to see that there from you in the chat, and we will weave that into the conversation here so we can learn from each other. I'm going to move on to our second consideration while the audience does a little typing there. And it's a maxim that I think is likely true in almost any industry, not just 3D. And it's the idea that it's vital to designate a project lead when we're adopting 3D print and understanding the value that this role brings to achieving successful implementation. So Kevin, I want to go to you first on this one, because this is something you've told me that you see, I think, rather consistently across successful organizations, is that they have a strong project lead that understands both traditional and additive manufacturing. I would love to hear from you. Why is this important in your view?
Well, I look at the two examples right here on the panel, Michael and David, because they understand traditional manufacturing and how additive can either complement or replace it where it's effective. And it's not about technologies, right? Like everyone can understand how things print, but to have a lead that really understands the application piece of it is really critical and isn't getting stuck in the day-to-day. The easiest thing that happens is we try to solve problems with traditional answers. And when you have someone ingrained like they are, Michael and David, and really changing their processes and understanding the application, that's where we've seen adoption rapidly grow and improve. I mean, I think of people like, I know Elon Musk isn't very popular these days, or Steve Jobs, but they thought differently. They changed their company. David talks about this growing revenue, doing products differently. That's why you need a lead. And those metrics that they talked about, someone who understands how it's returning the investment to the customer. So yeah, to me, it's critical that you have it. And again, it's not about the print technology. I can understand that, but I cannot understand what Michael and David do. And that's why you need someone like them to truly be effective in having success.
David, what about for you? The importance of a strong project lead in order to make this kind of rollout successful. Tell us your thoughts on that.
Yeah, companies are really good at standardizing and operationalizing things that they do. That's what gives companies scale. If you bring in new technology, you also need to bring in the mindset of saying, well, how might we utilize or change our operations or change our standards to accommodate that new technology? If you leave something to like their own, like if you leave every engineer or every person inside your company to like their own, initiative to like engage in additive manufacturing or engage in a new technology, like you're not really challenging them to like, well, how do I get value? How do I track value? How do we do all these other things that we were just talking about? So you need someone who has like the authority inside of the organization, and also like the ability to like track and like have these conversations around how our products are going to be different because of a digital printing technology.
That makes sense. Michael?
I'll add a quick point here. Yeah, everything that's said about the project, having your champion of additive internally, if you want to call it that way, that's super important. Yeah, all the things that were said already, all very important. I also really think that having executive sponsorships, so whether that's a vice president of engineering, of ops, someone in that kind of role that has the ear of, vice presidents or C-suite type folks, that's how you're going to ultimately move the needle on like getting buy-in at a higher level. And I see some posts in here about it's hard to get, the engineer and the designers and folks to like begin working with it. One, you need to make it easy for them. You need to make it easy for them, and they need to have standards and something to work to. So that's a recommendation there. But also you need your top-down leadership to ultimately buy into the idea and to help you drive that initiative, right? Whether that's setting goals, work with the vice president of engineering. Hey, let's set a goal. Everybody has to design one 3D printed part this year. Sign people up for webinars, bring in HP to, educate people on how to design for additive, or run webinars internally. Stuff like that is really important. I think you need to learn to start working with executives, because ultimately they're the ones that can sign off on $250,000, $500,000, $1 million, whatever the expense is going to be. You can't sign for that. So you need to work with them eventually.
Yeah. Kevin had a really good comment here. Many people don't want to change. And I strongly believe that. It's like, well, I think people actually that they don't want to change because the risk of failure can be really high, which is why you need an executive sponsor, right? Where it's like, we know we're going to try this. We know we might not be successful, but we're going to learn something from it that's going to transform the way that we, develop our product or the way that we manufacture something.
Yeah, absolutely. I have a question for the audience. This is kind of a counterintuitive question here, but I'm curious if anybody here has ever had an experience where you did not have a strong project lead or project sponsor, and yet a transformation as significant as what we're talking about here, perhaps even with 3D, if something of this magnitude was in the end pulled off. Were you able to ever pull anything off without having a strong project lead? I'd love to hear if there's any kind of counterintuitive anecdotes from any organization here, anybody's experience where this factor wasn't there and yet you were still able to move the organization forward. Just intellectual curiosity. I would love for everyone to share here. I'm going to talk about now our third consideration here, which is continuing on this theme of that project lead, the project sponsor. I want to know more about the importance of that individual's ability to focus on part development that leverages the additive manufacturing cell effectively. And Michael, I think I'm going to start with you here. Thinking back to how you gained momentum, how did you bring a focus to part development that leveraged the additive manufacturing cell in an effective way? How did you do that? You're muted still. There you go.
Sorry, the spacebar to talk thing isn't working super well. Just click on it. I think, yeah, this one's a great question. And I think the analogy I've developed over the years is like, anybody here who knows anything about machining or injection molding or rotomolding or any plastic technology, right? If you try to take a part that's been manufactured at your company for, let's say, 30 years, right? And you run thousands of them, you got the supplier set up, the tooling set up, the quality is all set up. If you try to take that part at the cost it's been, costed down for 30 years and said, we're gonna print this or we're gonna manufacture this, instead of milling it, we're gonna lathe it now. How would that go over? It would be awful, right? It'd be terrible. The part wasn't designed that way. Same thing if you took an injection molded part and tried to rotomold it all of a sudden and didn't change anything about it, it wouldn't work, right? So you need first and foremost, you need to, learn how to design for additive. It's not replacing anything. It's a new tool in your toolbox. And every additive technology has its own caveats, whether that's DLMS or binder jetting or multi-jet versus SLS. I mean, they're different. They have different things that they do well with, different parts they don't do well with. So I think where you need to start is go to a trade show, see what's out there, and then say, okay, I think, this technology are interesting for this and this application at my company. Let's call them up. Let's work with a service bureau. Let's get some parts in. Let's start testing and working with these parts. And I think you go from there. The ones you're going to design a bunch of stuff that's too expensive. It doesn't make sense. It's wrong technology. Let them help you. Say, hey, we shouldn't have done that with a carbon machine. We should have done that with multi-jet or whatever. Swap it back and forth. It's so dependent on your application, what you guys need or what your company needs. And I think you need to identify that right away, do lots of testing early on. Work with service bureaus first. They're the experts in it, right? And then it builds into, hey, we've really got the need for it. Then start working on a business case. And, hey, we should bring this in internal, right? I think that's the only way that it works.
David, how did you bring a focus to part development that leveraged the additive manufacturing cell effectively?
Yeah, well, first thing I did is I stopped looking at parts individually. Like this graphic we have, where it's like one part. Like these are flexible manufacturing platforms that can produce many different types of parts all at the same time. These, like, comparing a flexible manufacturing platform on the terms of like a traditional standard linear manufacturing platform, like injection molding, isn't even fair. It's like you're not using it for what it's actually, you're not measuring its strength, right? I could produce, this part plus 100 others of wide ranging capabilities and technologies, like, designs, and the spreadsheet can't display the value that's actually generated.
Huh. So how do you display that value?
Well, I stopped looking at parts individually. I look at them at like sets, where it's like, well, on this platform, right? For instance, like if I'm developing a vehicle or a printer, it's like, well, I have like X amount of capacity to produce digitally manufactured parts. Let's optimize that capacity, and then like identify like, well, how do we like gain the most efficiency out of it? How do we like if I was to buy an injection molding machine and you had excess capacity, you'd say, well, how do we sell it? The same thing with with like multi-jet fusion or these other additive manufacturing technologies. It's like you allot the capacity that you're going to have for it, know that you're going to get a valuable benefit to your business, and then manage the efficiency of it, manage the productivity, manage those things that make businesses profitable.
Audience, if you have any questions for David or Michael there, I think this is an important topic. I'm going to read something that Jordan just put in here. I think he was referring back to you, David. It says, does that only work for companies? What about service bureaus? Jordan, I think you're tying that back to David, if I'm not mistaken there. David, what are your thoughts on that?
Yeah, actually, I do think it does relate to service bureaus. And thanks for the question, Jordan. It does. And I think it comes down to, it's like identifying what that service bureau's product is. Like, is your product a prototype? Which I think is, like lots of them, we have that. It's like, what are these standard SKUs that you can like offer that like augment your like digital manufacturing products? Meaning it's like, is it like a digitized jig and fixture or nest? Is it something else that you can sell that like beefs up that like breadth, or maybe offers like standard SKUs that like use some of that excess manufacturing space that you might have?
So Michael, you're recommending a book here. It's called The Goal. Is that right? Yeah. Okay. I see.
Yeah, this is one of my foundational pillars of operational knowledge. It's a very easy to listen to Lean Six Sigma, kind of how operations work. One of the in the book, there's a bit where they're talking about normally they wouldn't take a bid on a certain job. And they found that if you think about the capacity of the entire plant, the throughput of the entire plant versus just the efficiency on that one machine, it was actually better to fill that machine up, even with some lower cost jobs, because it improved utilization and throughput through the whole plant. I'm not remembering the exact story out of it, but there's a good piece in that story in the end of the book about exactly what we're talking about right now.
Mm-hmm.
So that's, if you're interested in that problem, I'd recommend it. It's a good book to listen to, by the way.
David, I think you were looking for it back there on the shelf.
I've read it. Read it several times, and it's, to be honest, I talk about it. It's like basic, like basic manufacturing, but it comes down to this: anyone who's a service bureau on the call, if you have a prototype business that's paying for your equipment today, you take your production work at variable cost plus profit. Variable cost of the equipment running plus profit. Your fixed cost is covered by your current business today, and you extend your product lines.
So my team, let's find the Amazon link to that book and make sure in our follow-up that we include that. Michael, I'm sure, gets a good hefty commission on each sale of that book. I'm just kidding, Michael. But we'll find that for everybody. Kevin, I see a question here for you before we move off of this page. Brett asking, what is the software that we're seeing here that's giving the snapshot shown here? Kevin, what is the answer to that? Do you know?
No, honestly, I don't know where that comes. David, you might know. That's an HP.
It's a standard. Yeah. This is a standard way that like people.
David doesn't like it. He wants it more advanced.
It's looking at one part at a time is just like not. It's not like is it informed? It's like it's good information, but is that how the world manufactures? How would you manufacture something? It's like I wouldn't.
All right, Brett, let us know if you have any other questions on that. There's your answer so far, Brett. All right, I'm going to move us on. Let's get a little bit more detail here now in consideration number 4. I want to focus now on how the panel thinks about how to implement an additive manufacturing cell. Specifically, how do you set it up and the proper production process to employ within one. And I know that additive manufacturing has some specific workflow processes like traditional manufacturing, but I want to know, David, I'm going to go to you first here. What are the unique and let's call them key considerations for a 3D print workflow?
That's a tough question. Depends on what you're making, but I would understand. For me, I tend to focus on things around the printer, right? So making sure that like I understand like the value that the printer brings, especially production part, and then like how do I enable that pipeline of parts to like flow into the printer so that you can demonstrate value. So I tend to focus on like things like energy absorbing structures, fluid dynamic products, things like jigs, fixtures, nests, things where you know that you can win, and win with performance, like win and actually have something that's actually a better product, and help set up the organization to have those products flow in.
Michael, what about you here? What are the unique and key considerations you think are important for us to know when considering a 3D print workflow?
Yeah, let me, I'll define what I'm going to talk about before I talk about it. So it's a digital manufacturing technology. And the key difference is you're not sending a drawing to a machinist and then they figure it out, run the machine, make the part, right? And then they inspect it according to the drawing. So it starts all the way back at the design of the CAD, because when you create that STL or that step file and send it to the printer, that's what it's going to print. All the information is right there. So it starts all the way at design engineering, knowing how to design for the process. And nobody is going to fix your mistakes on the CNC operator is going to say, there's no way I can hold that tolerance. They'll call you up and they'll yell at you. And that doesn't have, the printer just prints it, right? So I think from the design all the way in the beginning, the design to the output of the machine, it's more connected than it was in CNC and traditional manufacturing, where you just send something off to someone else and they just take care of it. Printing isn't like that. So that's something that your designers really are, it flows all the way through, and whatever your designers are coming up with, they need to have an understanding of the manufacturing process more so than you ever did with CNC or injection molding and stuff, right? There's a little bit of that filtering, but not nearly as much. And then as far as once you're on the operations, what we're talking about, running your own 3D printing additive manufacturing cell, treat it like any other green sheeted process that you're going to bring in. If you're going to set up a new production line or a new assembly line or whatever it's going to be, what I found worked is I was trying to make the organization change to what digital and additive manufacturing is, and that didn't work. They hated that. And I basically spun my wheels for the better part of a year trying to get them to understand how additive can work, and trying to tailor and make all the processes how I wanted them to look in 5 years right at the beginning. And that was not the way to go. So what I did instead is I molded additive and I changed how I talked about it to match up with their language and their sheets that they have, the setup sheets and the P themas and the D themas and control plans, and go ask, hey, if you were going to set up your own thing for anything else we do here, what does that look like? And then mold additive into that, and then make the little tweaks around the edges that you need to. I think you'll find a lot more success in that regard, rather than saying we don't need drawings and you just send files and it just prints it and don't worry about it. They don't want to hear that. They're not ready for that. So you need to create that crossroads. And I think that's a good way to start with it. So that's kind of the operations side of it.
Kevin, I'm going to draw you back into the conversation here. And I know that one concern management always seems to have is part consistency, both in quality and repeatability. And I'm wondering, what are your thoughts on, from the organizations that you've worked with, the folks that you've helped, how should they go about setting up a production process that's going to ensure consistent output?
Well, it's almost reiterating everything we have just talked about, right? In regards to the processes, and Michael just talked about it, from input to output. Now we have ways to, track it, to follow a process that the output is consistent. So, going back to where I think additive has gone, technology hasn't rapidly changed over the last 5 years, right? MJF has been out there, Carbon's been out there. But what I see is, look at the way Michael and David are looking at it. And I think once we add those traditional manufacturing processes and thinking to additive, it's going to start improving kind of the overall implementation, and then we'll take it to the next level. So I think Michael just hit it on the head. You have to talk in the way that traditional manufacturers think, and then it makes sense. And we were one of the ones, when we look at some of the mistakes we had. I mean, I even listen as David talks about our one part view on the schematic there, or the
Screen.
image.
Yeah.
This is where we've messed up and haven't evolved quick enough. And I think that's but that's what's happening. And that's why we just need to convey it differently with management of people like David and Michael that understand traditional manufacturing and the processes.
Michael, I'm going to get you teed up here. So if you can unmute, tell us about how you go about setting up production process to ensure consistent output. Give us some insight there around how you think about that.
Yeah, I think it's been a great learning experience. I got my green belt 2 years ago, and I didn't really managing and operate like an assembly plant that's well set up and kind of already Lean Six Sigma to death already. I didn't really get a chance to flex those muscles. And when I brought this cell in, that was like my first time to like, you know, really go through what does an X bar and R chart mean? And what is the point, you know, how do I make this work into a P chart? And how, you know, what does 4 Sigma mean? What does 3 Sigma quality mean? Like what does all that intuitively mean? And how do you line it up and make it work? And I think those are the kinds of questions you have to get into. And, you know, I always say that operations is not a one and done thing. Like, right, engineering is you do the project, you launch it, and then you go on to the next thing, right? You do the project, it's done, and you move on. Operations is a daily grind. You show up at 7 a.m., you do it, everything has to go perfect all day long, every day, and then you go home and you come back and you do the next day. And that's operations is that march, right? And so the thing to go with it too, and that what I push back on and I've given constructive feedback to HP with is that quality is not, hey, we printed a whole bunch of dog bones and some measurement witness coupons on a printer in 2017. Here's the white paper. Our machines are qualified to, you know, whatever tolerance and strength and, you know, impact strength and all those engineering metrics. And that's great that they did that one time with that one machine in that one place with that one powder lot with those operators. You need to do all of that again with your situation, and then you need to keep repeating it to ensure that your quality is being maintained at whatever baseline it is, right? And then just being very, very intentional with what are your requirements. I think that's the other side of it, because you can go down the rabbit hole on quality and we need to be at 6 Sigma or whatever, and I'm telling you, you don't need that. Nobody, unless you're doing fully automated automation or automotive work, you don't need 6 Sigma quality. We found that 4 Sigma is fine. And really think about what does it mean to be 4 Sigma or 3 Sigma or 5 or whatever metric you're trying to hit. And then think about what is the cost and what's the time to develop and get to the point to hit whatever you think you want to do. Because every quality person wants to be 6 Sigma, right? But the reality is almost nothing is actually at that level. So really think about where do you need to be to meet your requirements, right? And then work with the engineering team. Can we design the parts in a way that they don't need this crazy tolerance? You know, can we design it in a better way so it's more appropriate for the technology and it's just a more robust part at the end of the day? So that would be my recommendation there.
David, you jump in here. What do you think?
You know, I agree with that. The thing that I've recognized over my years of building injection molds is that people put tolerances on things that the machine to like use as like process control parameters, as opposed to saying this is like a critical to function, you know, characteristic or dimension of the part. The other thing that people don't recognize is that these are batch manufacturing operations. They're not necessarily like, you know, so you want to measure it like it's a batch manufacturing operation, meaning maybe I have something inside of a build that I like 100% inspect, and then I just have little designed in features that I can like, you know, use a caliper check and pass a gauge R&R so that I verify that yes, these parts are printed consistently. But approaching a digital manufacturing operation with the same methodology that you for your injection molding operation or stamping operation isn't really the best method. It's expensive.
I see some good questions coming in here in the chat. I'm going to make sure that we leave enough time to get to all of those, as many as we can here in just a moment in the Q&A, but I want to make sure that we also hit consideration number 5 here before we get to your real-time questions. And, you know, Kevin, you mentioned Elon Musk a moment ago, and I think in a world that's gone remote first, work from home friendly, except in the case of Elon here recently, I think, though, we do need to discuss that certainly manufacturing in the way we're talking about here does require a physical presence, a physical workflow. And so I want to talk about the factory layout, the physical factory layout that enables us to produce parts from start to finish. So Michael, I'm going to go back to you here first. Let's get granular here because I think you'd agree it's important to lay out the additive manufacturing cell properly. And I'm curious, where did you start in mapping out your cell?
I mean, we essentially have at the moment, it's a clockwise cell. So you start with you can imagine it kind of being a loop, right? So we have one printer, we have one set of dimension finishing equipment, we have one processing station. So it's essentially the computer flows it right, is connected right to the printer. So the operator sets up the jobs to the printer, to the depowdering station, right? The next step in the process to the first dimension piece of equipment, to the dyeing system, to the power shot S, which is the polishing system, and then on to a bench at the end. And then the whole thing is like a U. So material comes in at the front and then parts to the receiving or going out of the cell is also all in line with, we have a lane for essentially on the outside of the cell. So it's a U that the materials come in and the materials go out, like finished parts go out, and it all lines up with that lane for the forklifts to run to. And then on the back side, the back of the U, essentially we have, consumable storage, right? That's where extra powder goes. All of our qualification samples end up over there, right? We've got a little storage cell on the back of the cell. So that's where it's just a big U essentially. And then it's just one process to the next. Yep.
All right, David, what about you? How do you think about the physical layout of the cell?
I like to I was lucky enough, like I worked at Forecast 3D after HP and during a time period where they were opening a facility in Michigan to really focus on the automotive industry and kind of like, the plan of like, they're a great organization by the way. And it was interesting as we were going through that, because it's like, well, there's one way that's saying, well, we know what works here inside of our beautiful facility in Carlsbad. Let's just, copy exactly to Auburn Hills and be able to provide like the same level of like quality and experience. What we had recognized is like, well, if you talk to your customers inside of that region and identify like, what do they actually need? What technology do they need? What materials do they need? And like, how do you design that system so that you provide the most benefit to your customers, to their quality metrics, to their, to what they actually need. And so they ended up creating a beautiful facility that's different than their facility in Carlsbad, which is primarily focuses on like high volume prototyping and like bridge production opportunities. It's very much a production oriented facility that takes all of these things into account, and from like a green field, which is like pretty bizarre from most companies' investment, but recognizing that there's a lot of growth in that market, it was a good business opportunity.
So audience, now's your time to get super engaged here. I want to get to all of your questions. If you've sent in a question or even a comment, if you see something differently than the panel, that's okay. We want to hear that conversation. Please repaste it back in the chat if we missed it. My team is going to start to surface those for me so that I can see all of your questions. I see Ferris, for example, reposting the one from Brett. Ferris, we'll have to get that probably offline. I don't think we know the name of that software, but please get those questions in. And as my team gets those ready, I want to make sure you have this opportunity. If you want to learn more from Kevin, or for that matter, any of the panelists today, take a moment to visit this URL. My team's going to drop this here into the chat, 3d.mastergraphics.com. And when you go there, if you have any questions about anything we've talked about today, anything you've heard about today, and you want to speak one-on-one with any of the MasterGraphics experts about any of these topics, as you've heard, Kevin's passionate about this and bringing you the knowledge and helping you advance your understanding of how to move your organization forward. That's what this form is for. You're going to see a page that looks like this. Take a moment to just fill in your details, your name, your email address, your company, your phone, and what your question is there. Hit that submit button, and then the team will make sure to follow up with you and give you ideas and offer you a helping hand. So Mindfire team, MasterGraphics team, please take a moment to drop in that URL, 3d.mastergraphics.com. And folks, please take a moment to fill that out if you have any questions. If there's anything we can do after this session to advance the conversation within your organization. So let me get to the real-time questions here. And I'm just going to go with what I see here first on my screen, which is a comment from Kevin. Kevin, by the way, thank you for being so interactive today. Kevin is saying the facility work is very important. You don't want to go back to management for more funding to do ventilation, environmental control, hazmat approvals after the fact, post-finishing space, etc. Panel, if I could just get you to raise your hand if you have something you want to reply to any one of these questions as they come in. Anybody want to say anything to the point that Kevin just made there? Anybody have a nasty experience with something like that, having to go back and ask for more money? Yeah, David, what about you?
I 100% agree. And I actually was working with a company that already spent a ton of money and had a beautiful facility, and they forgot like hazmat approvals for like the local the local codes, and
ouch.
Literally that like killed the entire division. So this is like a huge, like after you've spent 5 million and it's like, oh, what's another million? It's like, well, another million means you're not a business anymore, right?
Yeah. Yeah,
Michael, I saw
absolutely.
you raise your hand there too. Personal anecdote?
Ask for more money than anyone. They'll give you random quotes, double it, triple it. Ask for the money up front. If you're working for a publicly traded company like I am, it's so much easier to get it on the original AFE than it is to go back and say, hey, we need $5,000 more for, the quote came back from the installer, and, installing the electrical lines is going to be double what we thought it would be, right? I would, have a very good layout, like what, where all the water and all the air and all the electricity needs to go and how it needs to be lined up, what the benches are going to cost to build. I mean, like really get down to a bottom cost of like, what is everything going to be? And then I would like double it, because there's going to be stuff that you forgot about and didn't know you need. And if you've got a few extra thousand left over in the budget, it's there, you can use it. If you don't have it, it's so hard to go back and get more.
Yep, definitely. All right, so this question, I think I'd love to see if your hands go up, panel. I'll go to whoever is comfortable answering this. It's a question from Brett. Brett is saying, what is the piece part cost difference of running your own, let's say, HP 4200 work center versus getting parts from a service bureau? Now, I know you probably can't give an exact answer, but can anybody give some rule of thumb here? Anybody here? Or I'm going to call on somebody.
I mean,
Kevin, go ahead.
I can answer it. I know Michael's here. I mean, that's a very difficult answer because it all depends on geometry, size. I mean, rule of thumb, just like you're going out, it can be 5 to 15 times the cost of printing it internally, right? A lot depends on, again, application. So that is a very difficult one. Obviously, it's an easier one to really look at in regards to, I know there was another question on that graph of like, how did we create that? We obviously, as a reseller, can do a part cost study of what it takes to come internally, and then you can go out and get quotes. The only thing you all got to be also aware is a lot of times we're giving you the material cost, but you still have the machine amortization, stuff like that. But roughly, I would say 5 to 15 times. I don't know, Michael, if you want to shake your head, or David, but it really varies, unfortunately.
I think the key to success is competitive quotes, good relationships with suppliers. The same thing you do in your traditional business if you're sourcing an injection mold or sourcing a stamping or sourcing something else, right? The more risk, if you just like throw something over to someone and say, I need it tomorrow, well, of course it's going to be 15. If you say, oh, I have some flexibility here, and like you give a little and you communicate more, like that's going to reduce your costs.
Yep.
I see Michael give the generally accepted, I think, sign for, roughly, with his hands there. You did kind of one of these. So does that, Michael, mean you think roughly that what Kevin said is in the ballpark?
Yeah, it's like he said, it's super dependent on volumes. Are you going to be doing serial production? I like to break it down, and this is what you would do. Any buyer, any sourcing manager would do, right? Okay, well, give me a quote for 1, 10, 100, 1,000, right? And it's like, if you're ordering 1,000 of something, well, then it's going to be down closer to the 5. If you're ordering one of something once in a while with no guarantee of repeat business, it's going to be closer to the 10 to 15. It's just like any other process, right?
I know, panel, that we've reached the top of the hour here that we were going to be with everyone. I'm hoping that everyone can spend a few more minutes with us today, because I know there still are a few more questions. I know, though, however, that everyone's life is busy, so if you have to run, I have a question for everybody here in the audience before you leave and we get back to the next set of questions here. I want to know from you here in the audience, what stood out to you today? If there was one insight, one anecdote, one takeaway that was informative for you or that maybe influenced your thinking today? Would you give us that gift of that feedback? Would you put that there into the chat? I'd love to read some of those off because not only is it informative for us, but it's also informative for the rest of the room here. So please take a moment to do that. I know, Bill, you have to leave. Bill would love to hear that from you and from some of the others. If you can take a moment, give us your best insight that you picked up from the great panel today. And if you have to leave, just make sure to say thank you to the panel on the way out. We want to make sure that they know how appreciated they are. Here's a question from Kevin. Kevin said, what are the key parts of a PPAP that must be paid attention to when doing an additive manufacturing part for serial production? What are the landmines? Who can take that one here on the panel? Who's comfortable taking that question there? Question that came in from Kevin. All right, Michael?
Yeah, I think I gave a little bit of an answer. I would say before you read a white paper from anyone and say, oh, we can do any of those kinds of parts, right? Before you like base everything off of a white paper you read somewhere, do it yourself. Order the parts, prove it to yourself with a physical part, freeze it, hit it with a hammer, drop something on it, do tensile testing, right, on some sample parts in your facility. I would just recommend that. I think that's how you can avoid a lot of that. You know, I think like one that I ran into specifically is on like fluid handling, but for hydraulic oil. So HP, you know, it holds air, it holds pressure, it's watertight, but hydraulic oil is very thin and it tends to wick along the surface of the part. So yes, it will hold pressure and it won't lose any weight, but the oil will seep around the surface of the multi-jet part. And so it isn't acceptable for us because the outside of the surface is oily. So that's something I didn't know, but I originally planned on doing all kinds of fluid handling parts, which to me, water is like hydraulic oil, right? What's the difference? And now I know I should have, you know, done that testing, you know, early and often, and I should have tested that in real life with our application first. But that's something I learned. So that's what I would say. That's how you can avoid like design stuff. As far as PPAP, like quality witness coupons, measure lots of stuff. For us, it was just measuring 1,000 witness coupons over a year with all of the humidity, temperature, craziness, whatever, any questions that anyone had, just start logging your data in an Excel sheet, do an X bar and R chart, and just show, look, the parts are all within this tolerance plus or minus. There you go. That's a year's worth of data. I mean, if that's how your quality team is going to be, I mean, that's the only way that you can really prove to anyone that your machine's capable. So at some point, it's just doing the hard work of measuring a lot of samples. Oh, sorry, yeah.
Kevin added on to what you said there. You can learn a lot by first getting parts done from a service bureau, which I think is also obviously very helpful. Let me ask the panel this question here from John. John says, is it more important, in your opinion, of course, is it more important to have design and engineering engagement first or develop and propose an effective work cell first? Who would like to take a stab at that one? All right, I'm gonna call on you, David. What are your thoughts there, David?
You know, they're both important. It's like I would, you know, it's like good to probably the first step is like to engage with the technology that you want to develop a cell around and have a business hypothesis around it about how you're going to like generate revenue would probably be the first step. But then also like tinkering and playing and like figuring out like there's a lot that you're not going to know and that you're not going to like understand, you know. So like, you know, by doing that you can engage in like what that like business case is to identify like what are the needs actually of an additive manufacturing cell inside of your organization.
I know we're a few minutes over, folks, but I appreciate you sticking around. If you're getting value out of the panel here and their responses, please drop a yes or some X's and O's there in the chat. Just give them some love. I want to make sure they know how valued and appreciated their time is here with us today. I want to read something that Ben dropped in here. He says, I like this mindset. Quote, how can we change our standards to meet the new technology? And he says, panel, thanks for sharing all your experiences and helping lead this technology to the next level. Jordan is saying, great panel, smart guys here that have a lot of experience. Good reminders to always over-ask on the upfront of the business proposal. Yep. And don't leave the proposal short. Make sure you have processes written up for your additive cell. Thank you all. Absolutely. Good takeaway there. Erica saying, I agree. Use the same terminology and metrics to justify additive that are utilized to evaluate and monitor existing processes. Okay, that's a good takeaway. Kevin is saying you need to know your product lines. David is saying his key insight is, another David, we got a lot of Davids here today, David is saying, my key insight is don't treat this technology any different than traditional operational technology. Use the tools that are familiar and migrate to the newness that additive brings after building that foundation. I see you nodding your head there, Michael. John saying, thank you all very much for the time and insight. Gary is saying, thank you. Awesome, folks. Any other questions, please drop those into the chat, or if you have a key takeaway that you want to share, please take a moment to write that up. I'm going to ask the panel each one more question. I'm going to go with you first, Kevin, on this. Kevin, what's something that I should have asked you today that I didn't, that you think is useful for those that are assembled with us here this afternoon?
Well, first, thanks for the panelists again for joining us. But I think, I don't know, there wasn't anything that we didn't cover, but I think, why do you want to look at additive still, right? Like, why this case? And I just look at it, you got to understand what your internal pains are, because things like supply chain aren't going away. We have this challenge that's going to come on economically. And you really just got to look internally to where are the areas that you can improve your business's efficiency, their growth, and then, kind of look at this cell. David just talked about it, kind of looking at internally, understanding it, and building that business case. But I would say that's the thing, is why is additive still going to be important for the future? And it really is because it does address a lot of the pains we have, time to market, supply chain. And so start looking at your pains and then building your case if it makes sense.
David, what's something I should have asked you, or the audience should have asked you, that we didn't, that you think is meaningful to everyone here?
Yeah, well, I'm a plastics engineer, so I always tend to start with materials, and this is one panel I've been on where we didn't talk about materials at all. So it's cool. Yeah.
All right. Michael, what about you? Something that I should have asked you, something that the audience should have asked you that we didn't, that you think is helpful?
Maybe it's not like a specific question, but I don't know if we got to the idea of like a crawl, walk, run strategy with additive, maybe a little bit with like service bureau into, but it's really hard to go get $1 million right off the bat, right? Or to go from service bureau work to, okay, we're going to implement a multi-million-dollar thing. Like, and I don't know what the middle step is. HP needs to come out with the whatever, a medium-sized machine. That's what I'll always give them a hard time about. But I think you need to figure out what that crawl, walk, run strategy is going to be. I think walking or crawling is parts, maybe some service bureau parts. Maybe walk is ordering parts at a higher cost, but you're testing it, getting it on a product, and then running is when you've got your own system in place. So I think you really need to think about the scale of the dollars, right? Going from a desktop FDM machine to a full HP multi-jet production center. That's a huge increase in magnitude. So just consider how you're going to make those steps a little more achievable to not have to crawl up the face of a mountain on your first go around.
I see Ben here saying desktop MGF for the win.
Kevin,
what do you think?
I thought that was great. Oh my God, that made me smile. It's awesome. Brent or Ben, go join. Hey, the one other thing, just to build what Michael said on the service bureau, it's very typical. We see this, right? Even though we are a hardware reseller, we have a lot of great service bureau partners that we can connect our customers with, because most of the people we talk to, 99%, are not going to add HP MJF. But I think part of our duty to improve the overall success of additive is to make those connections. So don't be afraid of approaching us or anyone on this panel about thinking you have to buy a printer. We can definitely connect you with the service bureau, because that crawl, walk, run is definitely the right process.
So I see Eric saying, and my team will make sure that we do this, Eric. If this is helpful to anybody else, please let us know as well. Eric is saying, please send a follow-up email with at least the 5-point slide and brief bios and contact info for the panelists. So Eric, yeah, as Farah says here, the recording and slides are going to be sent soon to everyone. It looks like Beth added that on as well. So I still see Wesley, Tanya, Scott, a bunch of Scotts, Paul, Patrick, Mike, Leo, Lori, Kyle. There's still a number of you here. I know we're 10 minutes over, so I appreciate you sticking around. I'm going to give you another few moments if you have any other questions for the panel or team, my team. If I missed answering any of the questions that came in, please get those into me. I want to make sure that we answer all of your questions. Is there anything that's on your mind, or perhaps Here, Kevin, if you see anybody here in the room, in the virtual room, that you want to ask a question to who's been particularly conversant with us this morning, please take a moment to do that. Just if you can scan through the list there.
Yeah.
Let's see. Scott is saying, I love Michael being friendly to HP many times. Ha, ha, ha. Thank you, Scott. I adjusted your text slightly there. Scott says, nice, Michael. I see a lot of companies have to even qualify a vendor to do more than just test samples. There is typically a separation between validating a vendor for providing parts and then using those parts in a final product. Yeah, good point there, Scott.
Yeah, and hey, I would point out there's a couple of people from Engman, Taylor, Scott, and Jordan who are service bureaus. So feel free to drop your information there. And hey, David, earlier I put in the chat, but for anyone who attended the webinar, if they reach out to me and you were here live, I will send you the book that Michael recommended. It's the least I can do. I added no value to this panelist, but the one thing I can do, and Michael knows this, I can add value by buying things for people. So in all reality, if you send me a direct email with your address, I'll send you the book Michael recommended.
Wonderful, wonderful. Thank you for doing that. That's a great add-on there, Kevin. I'm sure you're going to get some requests there. Christmas has come early, certainly for some. Michael is saying HP is great. Yes, HP is great. Constructive criticism, yes, and they're always open to it, I believe. All right, anybody else here who's got a question? Lori, Josiah, Joseph, Jordan, James, Jean, we're holding the panel over. Eric, Don, I'm going to give you all another moment or two. And then if there isn't anything else, Kevin, I will give you an opportunity to bring us to a close, and then we will adjourn. Any other questions or comments for the panel? All right, Kevin, go ahead. Why don't you say a few words, and then I'll close us up here.
No, again, obviously, thank you, David, for running it and your team for supporting it, and the panelists. I mean, I love these kind of conversations. David Tucker, I love that you brought up, we didn't talk about materials. Like I said, I always love these to be informational, on it. So again, thank you guys for taking the time to share your great knowledge with no really benefit to you. So thank you for that.
All right. Now, I want to know, did you get value out of today? Please take a moment to drop a yes there in the chat. If you've got value, I want to make sure the panel's seeing that. Give them some thank yous. I see Scott saying, great panel, guys. Really enjoyed the discussions. Scott saying he's dropping an email here if you need HP parts. Okay, thank you, Scott. Ferris says, thanks for attending. David says, yes, thanks, everybody. Gene says, yes, got value, good. I'm glad you did, Gene. John says, yes. Tanya says, yes, thanks for all the great info. Jeremy says, thanks for all the great information. I'm glad to hear that you all got value out of today's session. As my team indicated, after this recording is lightly post-produced and we get the slides up, and if Kevin is going to make the offer of getting the book for everybody, we'll get a link up for that here shortly. You'll get all the follow-up information, and we'll make sure that if you also want either the first two sessions, you've indicated that by dropping your best email address in here at the beginning of today's event, we'll make sure to get that to you as well. So thank you, everybody, for being here. I want to thank the panel again. Michael, thank you so much for sharing of yourself so freely this morning. I see you nodding your head there. Appreciate you. All right. And David, thank you as well for your time. I really appreciate you spending your time with us here today. Thanks for the thumbs up there. And again, thank you to the audience. Thank you to Kevin for sponsoring today's event. And I appreciate everybody. Have a great rest of the day, great rest of the week, and leading into Thanksgiving. Hope everyone has a great time with friends and family. Bye-bye.